In the following video, we're going to examine how to find both the max and the min values of a function. So in this linear programming example, it says graph the following and find the max and min values of the function f of xy equals 4x minus 2y. And we're told these three inequalities. Your y value is greater than or equal to 3 and also less than or equal to 6. 3 is less than or equal to y, which is less than or equal to 6, which means your y is between 3 and 6, including those values. We're told y is less than or equal to 3x plus 12, and y is less than or equal to negative 2x plus 6. So when I look at these bottom two inequalities, I see they're already in slope-intercept form for me, so I don't have to do any converting. And if I look at this one, it's a little bit different. If we think about it logically, you see your y value is between 3 and 6, and it's or equal to, so it can include those values. And so remember, y equals our horizontal lines. And so I'm going to graph a horizontal line at 3, and I'm going to graph a horizontal line at 6, and I'll go ahead and use blue to represent this. So here's 3 on the y-axis, and here's 6 on the y-axis. And I'm going to do a horizontal line through both of those. And again, logically we can read it as the y value is between these. And so when I do my shading, my shaded region is between these two lines. And so then this is the shaded region. And so now I'm just going to graph the other inequalities. They're already in slope-intercept form for me. So y is less than or equal to 3x plus 12. I'm going to use green for this one. So I have a y-intercept of 12, a slope of 3. So I can't go up 3, right 1. So I'm going to go down 3, left 1. I'm going to go down 3, left 1. And so on across the whole coordinate plane. And so down 3, left 1, down 3, left 1, and down 3, left 1. And we see this is a solid line as well. So I'm going to sketch a solid line through all of these. And we're told our y values are less than 3x plus 12. So I want all the values that are underneath this line towards the lesser y values. And so if I were to shade this area, the whole idea is to look for the crisscrossing pattern. And when I see my crisscrossing pattern, it occurs in between the 6 and the 3 on the y-axis. And so just like I've been doing when it comes to systems of inequalities, to help me, I erase now where I don't see my overlapping, because then I know my feasible region is somewhere in this crisscrossing pattern. And so now I'm going to do the next one. I'm going to sketch the graph of y is less than or equal to negative 2x plus 6, and I will use purple for this line. And so you have a y-intercept of 6, a slope of negative 2, so down 2, right 1, down 2, right 1, and so on across the entire grid. And I can go up to left 1 as well. It's a solid line. Y is less than or equal to. So I would shade below this line. And when I shade below this line, I can see the crisscrossing pattern is occurring inside of this trapezoid there. And so since I see that this is where my overlapping occurs, I'm going to erase the rest of the shading. Do be careful when something like this happens, because if you look right now, you may think I've erased every part that I need to erase. But if you look, there's this triangular region up here that often is forgotten to erase. It is not part of the solution. Not all three colors are there. And so make sure you erase even this triangular region, because the trapezoid region here is where the solution is. So let's highlight that region like we've been doing. And so if I highlight that region, this is the feasible region. This is the solution space for this system of inequalities. And so now we apply our linear programming technique. We need to find the coordinates of our vertices and use those coordinates inside the functions. So if I look at my first one, I see a vertex right here, and that is the coordinate -3, 3. I come up, I see I have another vertex right here, and that is the coordinate -2, 6. I have a vertex right here, and that is the coordinate 0, 6. And this one is not on a perfect intersection of our grid. This coordinate is actually halfway between 1 and 2, so we'll say 1.5, and it's at a height of 3. And so these are my vertices. Now remember, we use these vertices inside our function. If you see the function of xy, this xy looks like a coordinate. It's inside parentheses, it has the comma, which means you plug in your coordinates, your x value and your y value, and determine the value of the function. So let's start with our -2, 6. So the function at the coordinate -2, 6 would be 4 times -2 minus 2 times 6. And that gives me -8 minus 12, so that is -20. And then let's do the -3, +3. So the function at the coordinate -3, +3, you would do 4 times your x, which is -3, minus 2 times your y, which is +3. So that's -12 minus 6, which is -18. So I just took care of these two coordinates. I'm going to need to take care of the other two. So I have f, the function, at the coordinate 0, 6, is going to be 4 times my x, which is 0, minus 2 times my y, which is 6. And that's going to give me 4 times 0 is 0, -2 and 6 is -12, and so 0 minus 12 is -12. And the last coordinate is the 1.5, 3. So you have 4 times 1.5 minus 2 times 3. And so you have 6 minus 6, which is 0. So now I found all the values of my function based off my vertices. If we go up to the problem, it says find the maximum and the minimum value. So I'm going to take a look at my values. To find my max, I see out of all these values, -20, -18, -12, and 0, 0 is the largest value. And so I have a maximum value of 0, and that occurs at the coordinate 1.5, 3. And I also want to know the minimum value. And so I see -12, -18, -20. Well, -20 is the smallest value. And so my minimum value is -20. And that occurred at the coordinate -2, 6. And so this is my answer. I state my max value, what it is, and at what coordinate it occurred at. I stated my min value, what it was, and at what coordinate it occurred at. So it's the same idea. You just find your vertices. Just realize your vertices are ordered pairs. Their coordinates x, y, and the function that is defined for us in the problem, the function of the coordinate x, y equals. And so you actually plug your coordinate in, the x value and the y value, and then just do basic order of operations. And we determine whether we had a maximum or minimum value in this.